In this session we are continuing with the module 3 energy systems, and under here we are discussing here the topics: the knocking and its mechanism, introduction to knocking and its mechanism in the internal combustion engines. Okay, what is this knocking? Knocking is, for starting that you should know the compression ratio. Okay, compression ratio in the IC engines. There will be a compression ratio. What is this compression ratio? Compression ratio is the ratio of the cylinder during the suction stroke. You should have studied this, friends, in your 10th standard. Okay, what is the compression ratio means? Compression ratio is the ratio of the cylinder volume during the suction stroke to that of the compression stroke. Okay, when this compression ratio increases, the efficiency of the engine also increases, only up to certain extent. Compression ratio increases, efficiency also will be increasing, but only up to certain extent. Beyond a particular combustion ratio, what will happen is a explosive combustion of the fuel and air mixture occurs here. Okay, beyond a particular compression ratio, explosive combustion of fuel and air mixture occurs, which results in a thermal shock wave. Okay, these waves hit the inner walls of the engine and piston, producing a rattling noise, which is referred to as a knocking. Okay, so what is this knocking? When in the internal combustion engine, when for example we are starting the vehicle, okay, two-wheeler or four-wheeler, what is happening? It is getting started and immediately you will be hearing a sound, grrr like sound, and it will be immediately stopped. You will be starting many times, you will be trying to start many times. When you are starting many times, what will happen? Okay, when once you start in the IC engine, what will be happening? Some amount of air and fuel is entering into the cylinder. Okay, it has not started. Once again, you will kickstart. So once again, some small amount of the fuel and air mixture is accumulated in the cylinder. Combustion is not taking place. Okay, so when you keep on starting, large amount of fuel is accumulated in the IC engine. Okay, so finally it get started. So what happens at the time? Rapid combustion of the fuel and air mixture occurs. Okay, large amount of fuel and air is there in the cylinder. Okay, rapidly the combustion will be taking place. Here what is happening is the fuel is not completely burnt. Okay, incomplete combustion. Because of the incomplete combustion, what happens? Okay, when I say incomplete combustion, surely there will be a formation of some byproducts. Okay, so due to the incomplete combustion, many number of the gaseous fractions are liberated here, and that high pressure and temperature inside the IC engine, already temperature is there. Okay, and at the temperature, because of some of the products liberated, pressure is also started. So at that high temperature and pressure, the products formed will be hitting the walls of the engine and piston at a high pressure, creating a noise that is referred to as a knocking. Okay, once again I will tell you, it's very easy to understand. Okay, in the IC engine, the efficiency will be increasing with the compression ratio. As the compression ratio increases, efficiency also will be increasing, but only up to certain extent. Beyond a particular compression ratio, explosive combustion of the fuel and air mixture takes place, which results in a formation of many number of the gaseous products. These gases produced at high temperature and pressure hit the walls of the engine and piston, creates a noise that is referred to as knocking. Okay, so the definition see here. Thus, knocking of a petrol is defined as a production of rattling noise, okay, sound as a result of explosive combustion of fuel and air mixture due to the increasing compression ratio. Okay, due to the increase in combustion ratio. Okay, and it happens due to the incomplete combustion of the fuel and air mixture. Okay, knocking occurs due to the explosive combustion of the fuel and air mixture. Your chain of reaction proceeds at a faster rate and produces unstable gases instead of carbon dioxide and water. Okay, these gases hit or knock the inner walls of the piston or engine, producing a rattling noise known as knocking. Friends, in a normal case of combustion, whenever a normal combustion, when we say, the fuels are supposed to get converted into carbon dioxide and water. Okay, that is under normal condition. Okay, if incomplete combustion is taking place, many number of the gaseous products will be obtained. Okay, and the efficiency of the IC engine increases with the increase in compression ratio. Okay, I already told this. Anyway, read once. Compression ratio is the ratio of the cylinder volume at the suction stroke to that of the compression stroke. Beyond a certain compression ratio, explosive combustion, okay, of the fuel air mixture occurs, which results in production of the rattling noise, which is referred to as a knocking. Fine. And let us see the reactions here. Under normal conditions, what should supposed to happen? Under normal condition, when the fuel is burning with air or oxygen, it will be producing a intermediate. The intermediate is called as a dimethyl peroxide. Okay, and the dimethyl peroxide, now it burns once again with the air or oxygen. As I said, it's unstable. It burns with air or oxygen to release a carbon dioxide and water. Okay, this happens under normal conditions. But under explosive condition, what will happen now? Under explosive condition, the chain of reaction proceeds at a very faster rate, and the fuel burns with air or oxygen. Instead of producing carbon dioxide and water, it produces a number of gases like formaldehyde, acetaldehyde, etc. And these formed gases hits the engine and piston, producing a noise that is called as a knocking. Fine. See here, under explosive conditions, the dimethyl peroxide liberated will be giving rise to acetaldehyde, and that acetaldehyde burns with air or oxygen to give formaldehyde, and the formaldehyde at last burns with air or oxygen to give carbon dioxide and water. So this acetaldehyde, formaldehyde gases formed are hitting the walls of the engine and piston. And here in this when they are asking this question, you must write under normal conditions 2 reactions you should write, and under explosive conditions 3 reactions you must write, then only you will be getting a full marks here. Okay, then what are all the ill effects of the knocking? Okay, what will be the ill effects? That is, it reduces the efficiency of the engine. It increases the power consumption. Okay, because now as the fuel is burning incompletely, the complete fuel is not converted into energy, right? Incomplete combustion. So the efficiency is decreased. Increases power consumption. Okay, because we are starting many times the vehicle, it is not getting started. Okay, so it increases the power consumption. Okay, more amount of the fuel is drawn inside, and also incomplete combustion, so the amount of the fuel used is more. Due to the rattling noise, the journey will become unpleasant. Okay, due to that disturbing noise, no, the journey will be becoming very unpleasant, we feel. And it damages the mechanical parts of the engine. Okay, because at high pressure and temperature, the formed gases are hitting the walls of the engine and piston. Okay, so it damages the mechanical parts of the engine. Okay, it's very easy to understand. Okay, what you have to start with, if this question is asked now, it will be asked like explain the what is knocking, define knocking, explain the mechanism of knocking. First you should write the definition. Okay, knocking is a rattling noise which is produced in the internal combustion engine beyond a particular compression ratio. Okay, that is due to the incomplete combustion of the fuel and air mixture. Okay, and you have to explain a little, that is the efficiency of the IC engine will be increasing when the compression ratio increases. Okay, but only up to certain extent. Okay, beyond a particular compression ratio, what happens? Incomplete combustion of the fuel and air mixture takes place. Okay, and this results in a formation of many gaseous fractions, and these liberated gases hits the walls of the engine and piston, producing a noise that is referred to as knocking. Then you should write under normal conditions, write 2 reactions. When the fuel is burning with air or oxygen, it will be giving dimethyl peroxide. Dimethyl peroxide is unstable. It will be giving rise to carbon dioxide and water. Okay, that is under normal condition. When a fuel is burning with air or oxygen, it will be giving rise to carbon dioxide and water. Then you have to write under explosive conditions. Under explosive conditions, what happened? The dimethyl peroxide formed, instead of producing the carbon dioxide and water, it will be producing many number of gases like formaldehyde, acetaldehyde, etc. And these formed gases are hitting the walls of the engine and piston and creating a noise that is knocking. Okay, and you must write with the ill effects. Ill effects is it reduces the efficiency of the engine, fuel consumption will be more, and due to the rattling noise, the journey will become unpleasant, and it damages the mechanical parts of the engine. Fine. What are all the prevention measures? Okay, what are the remedial measures? How to control? Okay, by suitable engine modification to use an optimum compression ratio. Okay, suitable engine modification should be done which uses an optimum compression ratio. When the compression ratio is optimum, you know that it will be, like efficiency of the engine will be more. Okay, so we can reduce the knocking up to certain extent, and by adding certain chemical substances referred to as a anti-knocking agents. Okay, when we add certain chemicals, they will be increasing the octane rating so that they will reduce the knocking rate. Okay, they are referred to as a anti-knocking agents. Fine, they are referred to as a anti-knocking agents, and you should remember always a fuel should have a this should have a very good octane rating. For petrol fuels it is octane rating, and for diesel fuels it is a cetane rating. Okay, when octane rating is more, when the octane rating is more is the octane rating, lesser is the knocking. Okay, so please to remember, more is the octane rating, least is the tendency to knock. Okay, so if a fuel is with a very good octane rating, automatically the knocking will not be there in the AC engine. Okay, and by using a high rating gasoline, we should use a gasoline which is a high rating, very good quality one, so that impurities will not be there, so that incomplete combustion will not take place, so that we can minimize the knocking. Okay, so this is about the mechanism of knocking. We will be shortly meeting with the new topic. Thank you.